I'm Samuel Sari.
I'm Antonio.
And I'm Giovanni Rivera.
This is our EDD project, Exhaust Pollution Regulator.
Alright, so we started off with something simple. We did a lot of research on it. Our background is many people throughout the world use lawnmowers. Many people aren't aware of the dangers they cause, like cancers or any carcinogens entering your body. 5% of all air pollution are caused by small engines, which is gas lawnmowers. And the EPA did extensive research in 2012, which reduced emissions from being 11 gas-guzzling SUVs to 4, which is a significant difference, but it's still not enough. It's still really bad for our environment.
A problem statement. So according to a study in 2012 by the US EPA, gasoline-powered lawn equipment was responsible for approximately 5% particulate air pollution. Fumes produced by gas-powered gardening equipment led to approximately 41 billion pounds of carbon dioxide and 13 billion pounds of air pollutants, and also carcinogens being released into the atmosphere. And the air pollutants, an example of the air pollutants would be carbon monoxide and nitrogen oxide, which is created by the combustion process inside a gas mower.
So our justifications, evidence has shown that air pollution causes many diseases such as strokes, respiratory diseases, and possible cancer. And then on the graph right there, we got the pollution generated. So as you can see, the gas power causes more pollution than the electric and solar. And that's really bad to the environment and to the people. Alright, so a lawnmower running for an hour can spew more air pollution than a Hillcrest student driving to Fort Worth.
Before we started our project, we sent out a survey to see if people were aware of these problems caused by a lawnmower. Our first question was,
Do you mow your own lawn or do you have someone mow your lawn? Most of the people said that they have a lawn service, so it was half and half on it.
Second question was, how many times a month do you mow your lawn? And as you can see, over 80% of the people said twice a month.
The third question was, do you use electric lawnmower or gas-powered lawnmower? As you can see, 88.2% said they use a gas-powered lawnmower.
The next question was, how long does it take to mow your lawn? And 42.9% of the people surveyed said that they take 1 hour to mow their lawn. Well, our last question was, are you aware that gasoline lawnmowers create more CO2 emissions than cars and SUVs? And as you can see, over 90% of people said no, that they were surprised to hear that.
And for similar solutions, we wanted to test different things out. Since we were working with the gas-powered lawnmower, we wanted to see how efficient an electric lawnmower was and how efficient a real mower was. We didn't have access to solar lawnmowers, so we didn't even try that. Our scale was from -1 all the way to +1. We ranked each of these things by that category, which for electric lawnmowers, it wasn't that bad. Its usage at time is not the best. Many people use it for a couple of years, and it doesn't really last that long. For reliability, of course, if it's raining outside, an electric lawnmower will not work. It may work for a couple minutes, but if functionality, it's okay. It's not as good as a gas lawnmower, and that's what we were trying to test. And it's not the very best. For environmental like purposes and all that, it's great. It's one of the best ones. You plug it in or you charge it, it's ready to go. It doesn't create as much pollution as a gas lawnmower. And durable, it is durable if you take care of it. Of course, it's going to last you, but it's not as good as a gas lawnmower, which lasts like years. So for that, the total was a -2. For a real lawnmower, that's a lawnmower where you just push and it doesn't produce any gas, nothing like that. That is really bad. Like to our environment, it's awesome. You throw no fumes, no carcinogens, nothing that affects our health. And you just push, it goes, but it's not what many people thought the U.S. works. Maybe like before it was okay, but to use this item, you would need something like a golf course. If you have rocks or your grass is way too big, this will affect this real mower. We give it usage time in life, it lasts a few years. It will last you a long time if you take really good care of the blades, but after that, it's really not that useful. It's really environmentally friendly, it doesn't use gas or electricity, you just push and that's it. It is durable, like I said, if you take care of it, you polish it, you fix the blades and all that, it will last you a long time. For that, we got a negative. And another thing that we tried was a catalytic converter, which is something that reduces emissions in all cars. This could have been an idea for us because it does what we intended it for. We intended our car for. It's practical. Every car has it. Reliable. It really is reliable. Cars last up to 100,000 miles with it without having any problems. And it's environmentally friendly. It doesn't clean like 100% of emissions or particulates or anything coming out of the car, but it's friendly. For that, we gave it a total of 3. Now for our sketch, we wanted something that resembled, like I said, a catalytic converter. We threw this in our notebook at first. We wanted something that could be easily connected to any lawnmower, like a Rarity, a Honda, or a Toro, and that could be easily screwed in or clamped in. At first, we wanted something that was around 10 to 12 inches long. Nothing bigger than that, because maybe it'll be way too heavy for a lawnmower, but that didn't happen. We wanted something that didn't cause as much noise as the original muffler or with no muffler. We wanted something that cleaned the air better. And for our first thing, we screwed it in. We did filters at the bottom and at the top, and in the middle we wanted a free flow of air, so it would create no back pressure.
So criteria for solution, we want the cost to be less than $15, no longer than 14 inches, and made from common materials that we could find in any store.
This is the materials for an EDD project: a black 11-inch pipe, an elbow, and a 1/2 inch to 1 inch nipple, nuts, bolts, and brass wool.
For safety concerns, we contacted some friends. We wanted it to be really safe for us. Of course, we were going to deal with a hot object. It gets up to like 1200 degrees Fahrenheit, and that's really dangerous for us. We wanted to always wear safety vests and check the temperature with a gun temperature gun. And
So the assembly procedures, we connected a 1/2 inch by 1 and adapted to the lawnmower. Then we drilled holes so the air could flow through. And then we inserted brass wools into the tube at both of the ends so it could clean the air.
As you can see in this picture, we took off the original muffler. We put the elbow inside to the exhaust exit, and then we attached we screwed on the 1/2 inch to 1 inch nipple, and then we connected our black pipe with the holes inside.
And then for assembly procedure, we tested this out a few times, and we did notice that the filters we use, which is brass wool, kept sliding off and pushing off because of all the air that comes out of the lawnmower. It's really powerful. So what we did is, of course, we used the nuts and bolts to put each one of them at the very top and at the very bottom, so it'll hold the brass wool in place.
This is the original muffler, which had 34 holes in it, and this is ours, the EPR, the exhaust pollution regulator, which had 10 holes, and at the top it had a diameter of 1 inch.
So at first, we wanted to make sure that the brass wool would withstand the heat. We tested it out with the heat gun, and it got up to 1,100 degrees, and that wasn't because like it didn't withstand it, but that's where our heat gun stopped. It didn't go any further than that. But other than that, it was great. It kept it didn't burn, and it didn't smell like anything burning.
Our testing procedure, we wanted to measure the difference between the particulate emissions coming from the muffler. We didn't have a scale sensitive enough to weigh the pollutant, so the only way we could show the difference was visually. Testing attempt 1, we used a wire mesh and white rag towel to capture the pollutants. We attached the white rag to the wire mesh and then placed the wire mesh around the EPR and placed the wire mesh at least 4 inches away from the original muffler, and then we ran each test for 1 minute.
So right here, this is the first try, and it burned the rag right there, as you can see. And on this one, we're trying to capture the air from the hole, so we can see how much pollution it causes, but that wasn't good because it was burning the rag on this one.
Our second attempt, we tried a PVC glue pipe. It was 6 inches. Only concern with that is that, of course, we didn't know how much heat it could withstand. After just running 1 minute, it melted. Didn't withstand it at all.
This is our the PVC pipe being attached to the muffler. This is how hot it got after we ran 378.7 degrees. And this is the PVC pipe being melted. The PVC pipe melting point is around 250, and as you can see on the previous slide, the muffler got up to 300. This is the white rag from the PVC pipe, and at first we thought that this was the pollutant, but it was actually the hot air from the muffler burning the rag.
So for testing attempt 3, we found a flat sheet of metal. We ran it with no muffler, and then we ran it with a factory muffler that it comes with, and then we ran it with our EPR. For each one, we did 1 minute, because that was like best for us. Anything over than that, we thought it would like burn completely what we had our test, and it showed significant differences. And for this, we secured it 4 inches away from the exhaust system for whichever it has it from. We ran it for 1 minute each, and we documented all we saw, and we repeated it 2 times, which for each time it showed around the same way.
This is us setting up the test. As you can see, we set the metal sheet 4 inches away from the exhaust exit.
So for this, as you can see, we ran it no muffler first because we didn't think it was gonna really work. So we messed up and did it all the way to the middle instead of starting it like A, B, C. So no muffler. It was since it had nothing connected to it, it threw out like particulates everywhere. It was like all around. With the original showed us that it worked. We read it at the same time, at the same distance, and it really better for us.
So our results were, after we tested the device with our two methods, the PR reduced emission, and on the last picture, it did show that with our EPR, it did reduce the pollution, and then we wanted to confirm that this did not add back pressure to the motor.
So for that, we just measured decibel readings. For no muffler, it was around 110 decibels, which is like ear hurting. It really hurts. It's really loud. You can't really talk and hear the person. For the factory one, it was like 90. It reduced like noise, but that's all that really does. The factory only reduces noise. It doesn't clean it. And with ours, it was around the middle, which was 98, which is still really good for just a filter.
Alright, so these are continual results. When we took off our device for observation, we noticed that the wool had black particles. Before we put it in, it was like brand new, and then after we took it out, it was all like black and stuff. This is how it came out. That's the before picture, and that's how it came out after we tried it with our EPR.
This is us testing it. Reflection, we tried 3 different test methods, 2 of which ended up burning our rads. The PVC pipes could not hold heat exceeding 300 degrees, and the cloth closer than 5 inches will burn at a further rate.
Conclusion, our design idea worked for the most part. It was hard to really test because we did create the holes at the side in the middle of our EPR. It was something that I thought of because if you create too much back pressure, the lawnmower would have started vibrating and would have caused something that we didn't want to. So that's what we did. We visually inspected this. There was no vibration on the lawnmower after putting in the device, and it ran smooth and efficiently.
Want to give a special thanks to Ms. Combs for aiding us throughout our project, and to her husband for helping us with the health hazards and drilling the holes into our pipe. And we want to give special thanks to the Academy of the Engineers and the judges for providing us this stage to present our project. Thank you.
Okay, now I'm going to let the judges ask questions. I know you guys are full of questions. Sorry, you don't get to ask questions. But Ms. Okura, I believe, has developed a Google form for the audience, or no, she hasn't. Never mind. Socrative, whatever, something different. Okay, so judges, if you have questions, just grab the mic and ask.
When you measured the sound levels, how did you know about doing that, and how far away did you put the microphone?
We did it at 2 inches apart because for cars, I know a lot about cars. I love cars, and like I know for California readings, you measure it at a 40-degree angle at 4 inches away. And for this, it's not that big. It's not that big of a exit, so we measured it like 2 to 3 inches each session system, and we just measured it with our phones since we didn't have enough for decibel, actual decibel reading. That's how we found it.
Okay, I was wondering if you analyzed and brainstormed other ideas. Because once you went over the similar solutions, you went right into this design. What did you change, or alter, or consider along the way?
Well, at first we did want an L shape because I know that for each lawnmower there's screw-ins or clamps. We were going for something like what we saw, kind of like a curve, but then we changed it into an L because we didn't have, or we didn't find what we really wanted at Home Depot or other stores. And we intended to use like either cotton, but cotton melts it after like 200, 300 degrees, and that wouldn't work out because it gets up to 1200 degrees. That didn't work out. Then I had an old bed, right, and I took it apart and I took the foam that was in there, and that sort of worked, but it melted right at 600 degrees and it smelled horrible, so we didn't use that. So after that, I know we used like grass wool to clean dishes, and we thought if it cleaned dishes, like what else could we clean? So we gave it a try, and it actually worked. It didn't burn up, so it was made of grass, so it could withstand, and that's what we did.
And at first we didn't have the hose, but we were seeing that the pipe was getting too hot, so we decided to drill holes so it could, more air could come out through it.
Okay. Yeah, so that would have been good to hear, you know, like your process of how you got to your final design, probably more than, you know, the similar projects that you did. One other comment, I just really want to say that you did a great job on testing in the photos with the arrows coming in, and it, you know, I'm a very visual person, so that really helped me follow your process. I will say that when you talk about the design criteria up front, you had a bunch of criteria there. Your criteria in your testing should really be aligned. So the things that you tested, the sound, the pollution, maybe they need to be weighted criteria instead of some of the criteria that you had laid out for yourself in the beginning. But great job.
Thank you.
Remind me of your cost again. I know in your specs early on, you said you wanted to keep it, I think, at $15. What did your final model that cost you?
Well, at first, of course, we didn't have a lawnmower on hand. We did a lot of searching. We found it for $40 in Craigslist. We had a difficult time to start it like running. Because of the cold, it just wouldn't start on us for like 2 months. We went through the process of fixing it. My dad, he's a landscape guy, like he does me a lot. And we did a lot of searching on that, and we finally fixed it. And we bought all the items prior to buying the lawnmower. And the pipe was around $2. The elbow was around $150, and the nipple was like around $150 as well. So it was less than $10. And the grass wool, we got it for free. There was a lot under my cabinet, so it was $15.
Okay, North Dallas group, are you ready to come in? Come on down. Okay, we have our next presentation is from North Dallas High School, and it is called L-Label, or L-Label, and it's Angie, Robert, and Juan. I'm going to let you come down and introduce yourselves.
Exciting guys. You guys look great. Let's do it.
Yeah.
One. So there's
So they were.
he's talking. Yeah, pass it to you.
I don't know.
Actually, no, you just keep one and they can pass between you two. I'll hold it for you then. How about that? Oh, we'll work with it. Gus and Tony, you're gonna go now.
We're changing.
Get him. Get him, Gus.
Hello. Good morning, everyone. My name is Mr. Carver. I'm from Woodrow Wilson High School, and technical difficulties, we're going to have one of our groups go next. So, I'm so glad to be here. I'm glad y'all are all here. This is super exciting. Multiple high schools together, engineering. I'm just like everything I care about in my life. So, we're going to start with a project called 60 Hertz Hum, and we have Anthony Marshall and Gus Teeter. They're going to go ahead and walk up onto the stage, right? Let's welcome them to the stage.
Alrighty, so as you know, I'm Gus Teeter, I'm Anthony Marshall, and this is our project on 60 Hertz Hum. Okay, so introduction, if you guys have ever played guitar, how many guitars we got in the audience? Alright, so a couple people will be familiar with this. If you plug in your guitar, you'll hear this consistent low buzzing noise, and it goes zzz, and this persists whenever you play guitar, whenever you plug in your amp. So, we had a previous project that we were working on for about 3 or 4 months. It was about traffic at our school. But after that, we had a democratic vote, and we all kind of decided that it wasn't going the direction that we wanted it to go. So it got canceled, and we had to go back to the drawing board. So I went home, and I played some guitar, and I realized that that noise was really bothersome, and I didn't enjoy it at all.